Hello and welcome to Ryan Cartwright teaches you how to graph a rational function. Now I hear what you're going to say. Ryan, I hate math. Fractions are scary. Graphs are even scarier. What makes you think I want to learn how to graph a fractional graphical thingamajig? And I hear where you're coming from. So, to make things a little less scary, I found a cute picture of a puppy. Alright. Everybody calm? Everybody good? Alright, let's start with the math. So, the first thing we gotta do when we graph a rational function is find the vertical asymptotes. Now these things are basically x values where the graph has no y value. The graph cannot really exist at these x values. There's a no-no. Cannot cross or touch these asymptotes. Alright, so if we find this out by factoring out the numerator and the denominator, and we get these values right here. X plus 2 times x minus 8, and this is a perfect square. We can easily tell this is x minus 4 times x plus 4. Okay, so the vertical asymptotes, we get those by setting the factors in the denominator to 0. Doing so, we get x equals negative 4 and x equals 4, and these are our vertical asymptotes. These are the x values where there can be like no y value. Alright, that is done. Vertical asymptotes in the bag. Okay? Now I find the horizontal asymptotes. These things are very similar to the vertical ones, but these are y values where there can really be no x value. Although the graph can be cross-ended sometimes. It's a little more loosey-goosey than the vertical ones, a little more laid back. Alright? A little more on their x-axis than their y-axis. That's a dumb joke, I apologize. Anyway, we can figure out what the horizontal asymptote is by looking at the degrees of the numerator and the denominator. In this equation, they are both the same. And when they're both the same, we have to divide the coefficients. And the coefficient, since there's no number there, we can assume that they're both 1. And 1 divided by 1 is what? But 1. Okay? So, our horizontal asymptote is 1. Y equals 1. That is where horizontal asymptote lies. But does the graph cross it? Now, figure this out. We have to set the graph equal to 1. Now, knowing that the graph equals 1, and we can see that there's negative 16 in the denominator and negative 16 in the numerator, we can assume that x has to, we can know that x equals 0. That way, the x's cancel out, and we're left with negative 16 over negative 16, which divided by those two numbers divided by each other equals 1. Or any two numbers divided by each other equal 1. Or any number divided by each other equal 1. Okay. So, x equals 0. Therefore, the graph crosses the horizontal asymptote at 0, 1, which we can know just by the x value being 0 is a y-intercept. So that is also our y-intercept, 0, 1. Now we gotta figure out if there's any slant asymptotes. Now these slant asymptote is basically when the degree of the equation is 1 more than the denominator. But in this scenario, they're both the same. So there's no slash asymptote. So we can just put none or a circle with a slash through it. You don't have to worry about that. Don't have to calculate anything. We're good to go. And now we already know our y-intercept from figuring out where the graph crosses a horizontal asymptote. So now we can focus on our x-intercepts, which is just like in any other graphical equation. We set the equation equal to 0. Doing so, we get the same factors we did up here. X plus 2 times x minus 8. Setting those factors to 0, we get the intercepts of negative 2, 0, and 8, 0. Now we're pretty much done. We have all the values that are important to graph in the equation. We just had to figure out where the graph is positive and negative. Doing this, an easy way to do this is having a line chart, putting 0 in the middle, putting both asymptotes on either side, and picking random x values in between those intervals to determine where the graph is positive and where the graph is negative, and plugging those values into the equation. So, for example, negative 6, when plugged in the equation, we get positive. So the graph is positive at negative 6. We get a positive value, so therefore it's positive. Negative 2, we get negative, and therefore so forth. We get positive, negative, positive, negative. That's how the graph will look. It'll be positive at -6, negative at -2, positive at 2, and negative at 6, around those intervals. So, all we gotta do is graph. And while looking at the puppy for distractions, I flip the page and reveal a beautifully drawn graph. Ooh, with colors and everything. Fantastic. Okay, so the vertical asymptotes, as you see, plotted at 4, -4, are in red, as in do not cross, do not touch. All right, the horizontal asymptote is in green. All right, kind of separating itself from the blue of the numbers and the axes, but saying hey, you can cross me. No, it's really up to interpretation. I don't know. That green is more friendly color than red. Whatever. So, now we gotta plot our points. As our first, we start with the x-intercept, which is a -2, 0, and 8, 0. Okay? Then we're gonna plot our y-intercept and where the graph crosses the horizontal asymptote, right there at 0, 1. Now we're ready to graph our equation. So we know from back here, from the sign chart, that at -6, it's going to be positive. And since we know that it can't cross the horizontal asymptote here, because it already has over here, and we know that it can definitely not cross the vertical asymptote, this is going to hug along this horizontal asymptote and hug all the way up this vertical one, creating that kind of shape, that kind of path right there. Okay? Now going back to this interval, 0 to -4, we know that it is negative. So I'm going to start from down here. I'm going to go all the way up, touching -2, 0, because we know that's an x-intercept, stopping right here at 0, 1. Because we know that on this interval here, it will be positive. So we simply just have to hug this vertical asymptote all the way up. And draw the arrow to indicate that it is going infinitely that way, but never touching the vertical asymptote. Now we know that this side, it is negative, so it has to be on this side of the horizontal asymptote, right? But never go into the positive region there. So we're gonna hug this vertical asymptote. We're gonna touch this, and we're actually going to cross the x-axis while hugging the horizontal asymptote, but never crossing it. And there's our graph. We're not touching the vertical asymptotes. We're only crossing the horizontal where we have to. And there it is. This is f of x equals x squared minus 6x minus 16 over x squared minus 16. See, it's not that hard, not that scary. You deserved an outlook,